Thank you very much for joining us. My name is Nehemiah, and today we are going to learn R, a full course on R. But before we begin, please subscribe, like, and share the video to your friends. And to the returning subscribers, I really appreciate you very much for your continuous support. Now, without much ado, let's begin straight away understanding what is R. R is a popular programming language and it is used for statistical computing and graphical presentation. It is commonly used to analyze and visualize data. So why should we use R, or why should we learn R? So R is a great resource for data analysis, data visualization, data science, and machine learning. It provides many statistical techniques such as statistical tests, classification, clustering, and data reduction. It is easy to draw graphs in R like pie charts, histograms, box plot, scatter plot, and so forth. It works on different platforms. It is supported on Windows, Mac operating system, Linux operating system. It is an open source and it is free. It has a lot of community support. It has many packages or a library of functions that can be used to solve different problems. There are about 9,000 plus, So, how do we install R? Guys, basically to install R, we are going to this website cloud.r-project.org, and then you are going to download the latest version of R that we are going to use in this course. Then also the other thing that we will download is the RStudio. Basically a place where we are going to write our codes. Of course, you can just write on R itself. However, it's a good practice to use the code editor. So guys, basically this is the page that I wanted you to navigate there. It is cloud.r-project.org, and then you are going to download for your operating system. You can choose to download for R. You can choose basically you can choose to download for Mac operating system, for Windows, for Linux, and so forth. Now, let me download for Windows. I'm using Windows, but for you can download for your operating system. The steps I think just straightforward. And then what you want to do here is to click on the base. So just click on the base. Click on the base, and then download R4.3.0 for Windows. I think this is the latest version at the time I'm recording this video. So let me click on it. Let me click on it so that it may download for this operating system. Let me just download this R. So guys, once the download is finished, just open it and begin the installation. So let's open it. And then just select your language. I'm using English here, so let me click on OK. Then next. Leave everything the way they are. Then hit next. So just click on no. You can choose to click on yes or no. And then what you do, click next, and then you can choose to create a to create a start folder, menu folder or not. Then what you do, hit next, and then you can create a shortcut on basically on the desktop, or you can just choose to leave it the way it is. So then what you do, let me click on next, and then I'm gonna extract some files. And so guys, once it's done, just click on the finish, and just click on the finish. And then guys, the other thing that I want us to do, of course guys, to download packages, you can just navigate to this page, to this packages page. Then you're gonna install your required basically the package that you want. So you can see the table of available packages sorted by date, and there are quite many here. So and they have some description here. So there are quite many guys. So there are thousands of them. However, we'll get back later. But guys, at this juncture, I want to show you how you can download the RStudio where we are going to write our codes. So just type in RStudio, and then click on this RStudio, and then let's download this IDE. So this is RStudio IDE. Let me accept these stuffs, and then let's click on download RStudio. So let's click on the free version. Let's click on the free version, and then guys, here you can see the steps here, or basically the requirements here. You need to have R, and of course you have just installed R. And then here we want to install this RStudio, the IDE for R. So what we do, it has detected my operating system, it is Windows, but for you I think it can be Mac, it can be Linux, or any other operating system. So let me just click on it so that it may download that R program for us, for me. So let me just download, and then let me pause the video. I'll get back later once it's done. So guys, once it's done, then let's open it. Let's open that RStudio so that we may begin to install it. So let's click on next. Next, let's install, and then let's finish. Let's click on the finish, and then let's find it and launch that RStudio. So far we have R in our system, and then we also have RStudio. So let me launch the RStudio here. Let me launch the RStudio, and then for me, I'm going to choose to use my machine's default, that is 64 bits. And then let me just click on OK. So basically here you can choose the rendering engine, but just select the default one. So guys, once you launch your RStudio, you'll have this kind of an interface. And I want us to begin by first understanding some of the basics R syntax. And for example, guys, if you want to execute some strings on your terminal, you just basically, first of all, let's understand. First of all, this is the your workspace where you are going to write your codes, especially if you want to save. And then this is the console where you can interact with your codes. Where you can write your codes and execute as soon as you write it. And then at this other end, we have the environment. So then we have also the history, the connection, tutorials if you want the tutorials, and so forth. And then at this bottom we have the panel for packages. You can see the installed packages here. And then we also have the files, we have the plots, and so forth. So guys, basically this is just very, very basics. I think you can understand, but first of all I want us to begin to understand what is the R syntax. Now for string guys, you can use a single or double quotes to define a string. And then just like for example, if you want to execute nametake, any other string, nametake, let me use nametake, and then now to run, you just click on this run button, then it's going to execute here the terminal nametake. So for integers, basically to output numbers, you just type the number without the quotes. For example, if it's 1000, you want to execute 1000, just write 1000, then it will be executed as 1000. Now if you want to do some simple calculation like 10 plus 10 plus what, 10 plus 10, you just write 10 plus 10, then you run. So guys, unlike other programming languages, you can output codes in R without using the print function. Like, remember in Python you have to use the print function, especially if you want to execute anything the terminal, but in R you just write and then you run the way it is, and then it will be executed. However guys, R does not have a print function available. If you want to use it, then this might be useful if you're familiar with other programming languages such as Python, which often uses a print function to output the codes. You can as well do that. For example, just say print. Remember, it should be in small. Print. Print. For example, let's type in our website. The string is you define with the ports www.nametech.com, nametech.com. This is our website. Of course, guys, you can find the reference to this course on our website. However, let me just show you in a few. So that, let me open a new tab. So guys, if you want to find the reference to this course on our website, just go to nametech, nametech.com, nehmtech.com, then go to R like this. Then it's gonna take you to the R page, and then you're gonna find the full reference to what I'm teaching you in this video. Find the reference here. You have the introduction, you have the syntax, you have the comments, variables, and many other stuffs here. However, I want to focus on the course, but you can always find reference here. And so now here guys, we're here. So guys, you can see that you can as well use the print function to execute some codes at the terminal, but remember it's not a must in R. And guys, basically there's times that you must use the print function to output the codes. For example, when you're working with the for loops, which you will learn it more basically later on this course. For example, let me just show you an example for that. Like if you want to use the for loop, you must use the print function. Let me first remove the indentation. Then let me type in then basically for x in 1 to 10. What I do, let me just, now here you have to use the curly braces. Now in these curly braces, this is where you can just write your print function. For example, if you want to print x. In so case, if you want to run it, just select the code that you want to run. For example, if it is this one, then hit run, and then I guess you can see it has executed 1 2. It has iterated over these stuffs here, 1 to 10 here. So guys, in a nutshell, it is up to you whether you want to use the print function to output the code, but when your code is inside an R expression, like in the curly braces, like what we did here, and then you have to use the print function to output the results. So let's advance, guys. Let's talk about the comments. Now basically comments can be used to explain the R code and to make it more readable. Remember, just like in any other language, the comments, they just help developers identify some parts of the code and understand the code more. For example, here I can just say, remember a comment in R begins with a hash. It starts with a hash. So basically R will ignore that part where it has a comment, or basically a line where it begins with a hash. So like for example, let's say let me say this is you begin with the hash, and then let me say this is a for loop. This is a for loop. So guys, basically let me select this code so that I may run it. So let me run this entire code, and then guys, basically you can see it has printed out 1 to 10, but it has not printed out this is a for loop. So basically guys, R ignores any comments. Remember, comments begin with the hash, So guys, the other thing here, just unlike other programming languages such as Java, there are no syntax in R for multi-line comments. If you want to insert a comment for several lines of code, you have to add a hash in each line. So for example, if you want to make this one a comment, you have to add the hash at the onset, at the start, to make everything a comment, a hash. Now when you run these codes, it will not be executed. When you run, it will be ignored. You can see it will be ignored because it is a comment, it will not be executed. Now let me talk about the variables. Basically variables are containers for storing data values, just like you can have something like a tank or anything to store something. Variables likewise, they are the containers to store the data values. So R does not have a command for declaring a variable. A variable is just created the moment you first assign a value to it. Now to assign a value to a variable, we use these tabs. We use the the angle bracket for less than, then followed by the hyphen or the dash. I think it's a hyphen, right? So you just do that. First of all, guys, let me try to clear this stuff so that we may begin properly. How can I clear these tabs? Let me just select all, and then I think I can clear. So let it be empty so that we may begin straight away. I don't know if you can see. Let me try to zoom in a bit. Let me try to zoom in a bit. Let me minimize these sections. Alright, guys, let me just make this stuff bigger for you to, so that we may concentrate on these on this these two parts, the console and these place where we are going to write our codes. So guys, basically I say that if you want to write to assign a variable, you have to use the angle bracket for less than, and then followed by the hyphens. So for example, let me say name. Let me declare a variable here. Let me say name, then let me assign it to. Now guys, basically to assign it, we don't use the equal operator like in Python. We just use the this angle bracket for less than, followed by the hyphen, and then you assign your values. For example, if it's name, let's say Nehemiah, let me use Nehemiah, right? Nehemiah Wekesa, Nehemiah Wekesa, and then let's create also the age. So age, let me say age, and then let me assign it to what? Let me assign it to let me say even 50 years of age, and then to execute these codes, you just do it to just say, for example, if it's name, just type in name, then when you hit enter, basically when you run these codes, it will be executed. Basically you have to select all these stuffs, and then where you run, then it will be executed Nehemiah Wekesa. So now if you want to get the age, just say age, and then when you run, then it will be executed. You can see age is it is 50. So guys, basically that's how you can create your variables. So guys, basically in other programming languages, it's common to use the equal operator. The equal operator is an assignment operator. In R, we can use both. You can as well use the equal operator and these ones to do it to assign operators. So, however, guys, basically the most common one, or the one which is preferred, is this one. They are basically the angle bracket for less than, followed by the hyphen. Because sometimes the equal operator can be forbidden in some context in R, so just use this one. So guys, I think of course, guys, you can as well use the print function, like let's say print for example age, print age. Then when you run, you can see it still prints out 50. Now guys, the other thing that you realize in this place, or in this script section, for example, if you want to execute something, you have to select everything. For example, if you want to select to do this, you can if you want to execute name, you have to select the entire code that is linked to that part for it to work. Because let me just, for example, if you want to execute this name part, just click on the control, then enter. It will execute the part for age, basically for age. Then for age, you just click on. You ensure that your cursor is here. Your cursor is here at the start. Then you click on the control, then enter. For example, if you want to execute certain line, otherwise you'll have to select everything there. So how do I clean these tabs? Here's my brush, right? Now, so basically that's how you can do that. And in a nutshell, it is up to you whether you want to use the print function or not to output your codes. R does not need the print function. You can just execute the codes as soon as you as you write it. So you don't have to write a lot of stuffs. Now let me talk about the concatenation or how you can concatenate elements in R. Now, for example, let's say let's first of all, let me clear everything here, and then for example, let me create a text or a string here, and then let me assign it to something like let me use a string here, and then let me say name tag is awesome. Name tag is awesome. And name tag is awesome. So guys, basically, if I want to concatenate, you have to use this function called paste. If I want to join two or more elements, we use the paste function to concatenate. So you just say paste, paste. Then inside this paste, you can type in your string, for example. And then let's say, for example, if I want to just type in text, that's our variable. Then you can say, you can concatenate. To concatenate, guys, you just say this will be name tag is awesome. Let me just say find. Now it's a string. Let me say find a reference to this course here, and then www.nametech.com. So guys, when you want to run this code, just select everything here. Just select these two stuffs. Then what we do, let's run and see if it will be executed. You can see name tag is awesome. Find reference to this course here, and then www.nametech.com. So guys, basically you can see how you can do that, how you can concatenate. Of course, you can as well do this. Let's try to concatenate what? Let me first of all clear these tabs. Then let me, for example, let me use num1. Let me assign it to something like not really. Let me use I'm used to Python, but let me use this one, for example, 10. And then num2. Let me assign it to 20 perhaps. And then now guys, basically you can as well concatenate with what you can for numbers you use the operator, the plus operator, for example, if you want to concatenate. So for example, you say num1, then a plus num2 like this. Then when you run, num2 is not found. Oh guys, basically sure it's not found because it should be 2. I should have said 2. And then let's try to run and see if it will work. So here you have to do it. Yeah, here you have to select everything before you execute. And guys, remember you cannot concatenate the string in the integers. It will give you an error. It will throw an error, like let's say text, for example, text, and then let me say name tag. Let me say name tag. Then now let me just try to select everything. You'll find out that it will bring an error, right? So oh, here it should be now text. Sorry, it should be plus text. Then let me select everything. Then let me run, and then again you can see it brings an error, a numeric argument to binary operator. So it can't work like that. And so let me talk about the multiple variables. So guys, basically R allows you to assign the same values to multiple variables. Like for example, if I want to say, let's say, let me clear everything here. First of all, let me try to zoom in, and then here guys, let me assign the same value to multiple variables. Like let's say var1. Let me assign it to, and then let me assign it to var2, and then variable 3 perhaps, and then assign it to let me assign it to what? Let me assign it to, now this is a string. Let me assign it to name tag. Let me say name tag, right? Let me say name tag like this. Remember, string should be inside the quotes. You can use either double or a single quote. Now the print function or some to be executed, let me just write, for example, var1, then also var2, then var3. You'll find out that it will print name tag 3 times. Let me select everything, then let me run. Then you can see var1 it is name tick, var2 is name tick, var3 is name tick. So it has, it has you can as well assign many variable to a particular value, so guys, let me talk about the variable names or identifiers. Now, a variable can have a short name like X, Y, Z, and so forth, or a more descriptive name like age, car name, total volume, total mass, age, and so forth. But here are the rules when naming your variables. A variable name must start with a letter, and that can be a combination of letters, digits, and periods. Periods, that is a comma, that is a full stop, and of course the underscore. If it starts with a period, it cannot be followed by a digit. Now, a variable name cannot start with a number or an underscore in R. And then the other thing is here is that variable names are case sensitive, just like in Python or in other languages. Like for example, let me just show you guys for you to understand what I'm talking about. Let me just say, for example, age. Let me assign it to what? Let me assign it to 40 perhaps. Then here let's say print. Not really print, just say age. And then when you run age, don't know if it will work out. You can see it's 50, but when you say age like this, remember they are both age, but the other one is small, then the other one is capital. And when you run that age, it will say object not found, so they are different. It is case sensitive. Then the other thing I said that it cannot start with basically with a number or an underscore. Like for example, let me first of all clear this stuff. Like you cannot say to age. You can say age 2 but not to age. Let me say 2 also. Then what I do, let me just try to run and see. You can see it brings an error, right? So it cannot begin. But if you say age 2, it will work out. It will work out if you say 2. Then if I want to execute age, then basically age 2 not found, right? So I should have placed here. Let me select everything. Then let me run, and then you can see it does. So basically, that's the rules in R, and reserved words cannot be used as variables or are the built-in keywords in Python in R, like the logical or basically the booleans like true, false, and other keywords like null, if, and so forth. Those built-in keywords in R, you can't use it. You can't use them as 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 a variable names. You can't use them because it will throw an error. Now let me talk about the R data types. R data types. So in programming, data types is an important concept, and variables can store data of different types, and different types can do different things. Now in R, variables do not need to be declared with any particular type, and can even change the type after they have been set. Like for example, let me show you guys an example for you to understand, to grasp everything. Like let me use let me use here snake case variable name. Remember, snake case begins with they are both small letters, but we separate names with a underscore. Like my variable, then to assign it, you use the angle bracket for less than, then followed by the hyphens. And then for example, if you say 30. Remember, this one is what? This one is a numeric. And then what you do, let me just here let me say what? Let me say what? So guys, basically you know that when you print out my underscore var, it will do what? It will do what? It will run. Let me run first of all, and then oh sorry, my var not found. So you have to select everything now. That's So guys, you can see it is you know 30. You can as well change, for example, again, sorry, let me just use this one, then let me assign it to a new value, like let me say sorry, let me say here, like let me use a string, like let me say name tag, then here, and let me do it, let me just say let me say here my underscore var, but let me try to select everything, then let me run and see if it will work. Here guys, you can see now it is name tag, it has not printed out 30. Let me try to run again. Yeah, you can see it prints out a name tag. So it you can change what you can change, it can be modified once it has been set. Now R has a variety of data types in the objects, basically object classes, and I will learn more about that as we go on. But basically the basic data types in R, we have the numeric, they are like these ones: 30, 40, 100.5, 10.5. And then for integer, you also have another data type called integers. Remember, in other languages that is like an integer, but in R, to define an integer, you have to extend with capital L here to show that it is an integer. And then we also have the complex. Complex, this is where we can have a combination of number, and then you concatenate with some imaginary part. Imaginary, talking about imaginary, can be something like this. Let me show you. Let's say, for example, it is for example 9 plus 9 plus, for example, 3i 3i, like this. So basically, this one will define that is an imaginary line. So this one is a complex, and then we have the characters or a strings. This is anything that is inside the quotes, be it a single quote or a double quotes. Then we also have the logical. In other languages, it is called the booleans. These are true or false values. So for example, let me show you that, guys, and of course I'll show you how you can obtain the type of the variable. And of course, let me begin let me use simple ones like x to declare a variable. Then let me assign it to something like a 10.5. We know very well that in other languages this one is a floating number, a float, but in R it's gonna be what? It's gonna be numeric still. So here let me say class of x. Let's find the class, then let me select this code, then let me run, then you can see it is numeric. And then for example, if it's L, for example, let me just say, for example, 1000 capital L, then when you run, it will be what? It will be integer. You can see it is an integer now. And now for a complex, let's say, for example, 10 plus 10 plus, for example, 50i or imaginary. Then what I do, let me run. You can see it's a complex here at the terminal. And then for example, for a string, we all know that anything inside the quotes can be let me say name tag. So this one is a string, right? A string, you can see it's a character or a string. And then for example, if you can also I say that anything inside the quotes is a string, is a character. For example, we all know 100 is an integer or a numeric, but once it's inside the quotes, it's going to be a character still. Then you can see it's a character. And then the logical ones like true or false, those are logical operators, like let's say true. Now in Python we use true, it begins with a capital, and then the rest are small letters. But in R you have to use capitals to define your logical operator. Like if it's true, it must be capital to define that is a Boolean keyword. Now let me run these ones, and then you can see it is logical. So these are basically this is about those data types. Now let me talk about these stuffs in detail. Let me begin with the numbers. Numbers, there are three types of numbers in R. That is a numeric, that is integer, and also the complex. So basically, those are examples of numeric numbers. And of course, for example, let's do it. Let me show you that example. Or guys, basically, I thought I've just showed you, but I think it's wise also to show you again so that we may wrap this section. So for example, let's assign x some. Remember also R is case sensitive. I told you that. Now this one we all know that is a is a numeric, and then let's say y. Then let me assign it to even 10. And then let's say print. Let's print what? Let's print the x and y. Let's select everything. Then let's run. And then now you can see it has printed out x is 10, and then x is y. Of course, you can as well obtain the class. The class, for example, class of x. Class can be of x. Of course, and then a class of y of x. Now let me select everything, then let me execute. Then you can see it is numeric. Class of y is numeric, and then the other one is they're both numeric, right? Remember, anything that has l, or remember, integer is anything that don't have the you know the decimal. That's you know, an integer, you know. So guys, basically this is all about that. And of course, let me talk about the math. Let me talk about R math. Now in R, you can use operators to perform common mathematical operation on numbers. Like a plus operators is used to add two values. And let me show you. For example, 10 plus 90. When you run, it will be 100. And then for example, minus. When you minus, it will be negative what? It will be negative, I think, 80, negative 80. And then you can as well, guys, of course, we have the built-in math functions in R. R also has many built-in math functions that allows you to perform mathematical tasks on numbers. For example, the minimum, we have the minimum, the mean function, the mean and max function can be used to find the lowest and the highest number in a set. For example, let's have a set. First of all, if you want to obtain the maximum, you say max, and then inside the parentheses, you can define your numbers, like let's say 20, 12, 1, 39, any random number, any random thing, and then what we do, let me run. So it will find the maximum number here, and we all know it's 50. Then you can see it's 50. If you want to obtain the minimum, just say min, and then when you run, it will be at 2. So 2 is the minimum number there. We also have the square root. For example, if you want to obtain the square root of something, let me just use the sqrt for square root. And then for example, for 64, let's run. It will be 8, right? It will be 8. And then for example, if you want to obtain the absolute value of something, like I say, we just use abs. And then for example, let's have negative 30.9, something like that. Then what I do, let me run. Then we can see now you have the absolute value here without the negative. You also have the ceiling and the float. Let me say, for ceiling, we use the ceiling function. For example, 1.5. When you run, you'll find the ceiling. It will be 2. It will be 2 because it's above 5. It's above 5. Basically, it's 5 or above. Remember, it rounds off. Now, if it's 4, it will be 1, right? For example, 4. when you run, it will, this one it should be flow, right? It should be flow. If I want to, let's say flow. Remember ceiling, it will shift to the upper integer, and then for flow it will shift to the lower integer. Like when you run, it will be 1, you know. So guys, basically that's how you can know the math function. However, let me talk about the other thing. Let me talk about the strings. I think, of course, guys, I talked about these things, but let me just rewind. And of course, guys, I said that for strings you can use a double. You can use either a double or a single quote. Let's begin with the single, and then let me say name tag. Name tag. I'm using name tag always so that you may be familiar with our platform. Then you can see it's name tag. And then let's do this. Let me use a double quotes. Then let me type the website name tag .com should be com, and then when you run, it is what it is. It is, you know, it is an integer. Of course, to assign you can as well use variables to assign to something. Like for example, if you want to say this one to be a string, right? str, you can do it, and then you remember the assignment use angle bracket for less than followed by the hyphen. Then when you run, for example here str, this str here, when you run, it will be what? It will be, let me select everything, then let me run, then it's now, you know, name tag. So also you can have the multi-line. Remember, you can assign a multi-line string to a variable like you can have multi-line variables like, let me say here is awesome, is it so you can have multi-line, then when you run, it will still obtain these results. But remember, by default, R will do what? Will add this n, this backslash followed by n to show that it's a broken line. You know, it's we have the break tag. So basically, this one is called an escape character, and the n character indicates a new line. This is escape. This backslash is an escape character, and then n, it shows that it's a new line. So guys, if one the line break to be inserted at the same position as it is in the code, you have to use the cut. You have to use what? The cut function here, the string. So let's say cut, and then I should be now inside there, and these are steps. Then what I do, let me run. And then now guys, you can see now we no longer have those stuffs. Those are, you know, those are backslash and are followed by the n to show the break, whatever. So basically there are many useful string function in R. For example, to find the number of characters in a string, we have to use the nchar function, or a number of characters. So you just say, for example, if you want to find the number of characters here, you just say nchar like this. Then when you run, you obtain the number of characters. Here you can see it is 33. When you count, it will be 33 and so forth. For example, if you want to check a string, we have to use the grepl, a function to check if a character or a sequence of characters present in a string are strings or not. So for example, let me just find an example here. Let me use here. Let me say grep. It should be grepl, and then here let me pass in what? Let me pass in. Let me begin with the w, right? Let me begin with w. Then let me try to run and see if it's I think. Oh, guys, basically, you should also define the part that you are targeting. First of all, separate with the comma, then you target the variable. It is str like this, and then what you do, let me run again and see if it will work out, or it will still bring the error. Then you can see it's true because W is a string there. So yes, that's how you can do that. Of course, you know how to combine the integers, basically the strings to combine it. Just so let me just show you. For example, string one. Let me assign it to uh, name tag, and then string 2, str2. Let me assign it to is awesome, right? Is awesome. And then to execute or to concatenate, we have to use the paste function to concatenate them. And then we are gonna pass in str1, and then you separate with a comma to concatenate, and then str2, str2 should be true, right? Like this. And then let's try to run and see if it will work out, or it will throw an error. Then you can see name tag is awesome. We have concatenated that stuff. So that's how you can work with the concatenate stuffs. So let me talk about the other thing here. Let me talk about the booleans. And of course the booleans in R, they are called the logical values. In programming, you often need to know if an expression is true or false. You can evaluate an expression in R and get one or two answers, like true or false. So when you compare two variables, the expression is evaluated and the R returns the logical answer. For example, let me show you that. For example, if you say 10 is greater, 10 is greater than what? 10 is greater than 9, right? Let's try to run. Then when you run, it will be true because 10 is truly greater than 9. But if you use the less than, like this one will be what? This one will be a false statement, Now for equal, guys, you have to use two assignment operator like this to show that you're equating. And then when you say 10 is equals to 9, that's wrong because 10 and 9, they are not equal. It will be false. But if you say 10 equals to 10 should be 10 equals to 10, then it will be true statement there. So guys, you can see that having these these logical stuff, they are quite important because it can help you understand other stuffs. So of course you can also run a condition in an if statement. Like let me show you that. For example, let me say a, let me say is greater, basically a, let me assign it to a value like let me say even 100. B, let me assign to a value like let's say 50. 15. Then here let me use an if statement. Here let me say if and then let me say B is greater, B is greater than what? B is greater than A. B if A is greater than B, right? Should be let me just B is greater than B is greater than A. B is greater than A. Then let's write our condition here. We use the braces. Let me say here I'll say print, and of course guys, I say that R does not need a print function to execute the course at the terminal, but I say that if you use the condition like if, for loops, and others, you have to use what is the print function to execute only those stuffs, the condition and the statements. That's when you have to you must use the print function. So like let's say print for example B is, so for example guys, if B is greater than A, we are gonna say B is greater than B is greater than what? Than A, right? And then otherwise, now that's when we use the else keyword. Let's say else. Let's say else. Of course, you can say else. else, and then let's add in that these curly braces again, then else, let me say print b is smaller than a. Of course guys, it should be a string. This one is a string, so it should be inside the quotes like this. Also guys, this one should be let me use a double quote so that can be unique. So let me try to run and see if it will print something valuable. Then you can see b is greater than a. Why? Because b is 50, then a is 100. But if I change the operation here to be less than, then when you run, it will be b is greater than a. So you can see b is greater than a. So guys, basically that's how you can use those statements to change the logical from the default or logical operations, and then you use what these are statements. Now let me talk about the operators perhaps in detail. So operators are used to perform operation on variables and the values. Like in this, let me show you guys an example here. Let me just show you an example. Like for example, let me use an equal operator here. Like I said, let me say 10 plus 90. So this plus operator is used to add two values together. When you run it will be 100. And then we remember minus is to subtract something, some values from something. Then you can see it's negative 80. So basically R divides the operators in several groups. I think there are 5 groups. We have the arithmetic operators, we have the assignment operators, we have the comparison operators, we have the logical operators, we have the miscellaneous operators. Perhaps let me begin with the arithmetic operators. And arithmetic is what I'm showing you. For multiplication, use this asterisk, right? Asterisk, and then when you run, it will be 90 times 10, it will be 1000, it will be 900, right? And then for division, we use this the forward slash. Then when you run, it will be 0 point whatever there. And then for modulus, or the remainder from division, we use the 2% symbols. It will be the modulus. When you run, it will be the modulus, or the remainder from the division. And then for integer division, you use percentage, then a division operator, then a percentage, then you'll get what? You'll get the integer division, and then it is 0, of course. Now let me talk about the assignment operators. Now assignment operators gives you can use to assign something, like what we've been using, we've been discussing. Like for example, if you want to assign values to something, like you can just, for example, my underscore var, then you can use these stars. For example, if you assign to 3, so this one is an example for what? Of an assignment operator. This one is an example of an assignment operator, and of course you can also use the other way around, like this way. It also does, it's an assignment. Of course, you can use also the double. So basically, these are examples of assignment operators. Now for comparison operators, we have several. Like for equal, we use 2 equal operators. For example, let's say 10, then let's say equals to 10. Remember, you have to use these two equal operators to show that you're equating. You can see it's true. Then for not equal, for example, if you say If we say if we add here an exclamation, it will be, this means that a 10 is not equal to 10. This one will be false because we all know that a 10 is equals to 10, right? Let me run. Then you can see it's false because 10 is equals to 10. But if it were 9 here, or any value less than 10, it will be a true value there. And of course, we have the greater than and the small less than, and of course other stuffs. However, let me talk about the logical. The logical operators are used to combine conditions and statements. Miscellaneous operators are used to manipulate data and so forth. Let me talk about something else, guys. Don't want to dive into that. Don't want to waste my time on that. And of course, you can just relate, or you can find the reference on the website. Now, let me talk about the statements, the condition, the if and the else statements. So R supports the logical condition from mathematics, like what we discuss here, like these are not equal to or are equal to something and whatever. Basically, this condition can be used in several ways. Most commonly is in if statements and loops. Now, let me talk about now these if statements. So, an if statement, it is written with the if keyword. Remember, guys, I said that the built-in keywords you can't use to define a variable. Like you can't say, can't call your variable if because it's a built-in keyword in Python. Like yeah. And then let me show you an example of an if statement here. For example, first of all, let me create a variable here, and then let me assign it to 20 parts. And then B, let me assign it to another values like let's say 980 80. Then here let me use an if statement. So let me say if for example b is greater than a, b is greater than a, and I guess you remember we talked about these stuff just in a few, but I want you to understand these stuff. So here you'll say print if b is greater than a, let's print out b is greater than a. B is greater than a. Let's run and see if it will work out. Then you can see b is greater than a. So also you can also use the if else if and the else if. So basically the else if keyword is basically is an R's ways of saying if the previous condition were not true, then I try this next this second condition. Like for example, you can also say else if else if and then here let me pass in perhaps let me say else if for example let me use 2020 then let me say else if a equals to b, else a equals to b, and then here I can pass here, let's say print remember I told you once again, let me repeat, I said that in R you can execute the codes without using the print function. Just as soon as you write it, you can execute. But for conditions, for if statements, for loops, you have to use the print function for it to work. You must. Just note that. Then, for example, here, let me say, for example, A and B are equal, right? Let me say equal. A and B are equals. Let me try to run and see if it will output something. Then you can see A and B are equal. So that's how you can use the else if. Once again, when you use the else if in R, it's like saying if the previous condition were not true, and of course it is not true, B is not greater than B, and then if the previous condition were not true, then I try the next condition, and then that's when we say B is greater than B equals to A equals to B, and we printed out it is true. So that's how you can use it. Of course, we also have the else, if else. Now the else keyword catches anything which is not caught by the preceding condition, like for example, if you have B is not greater than, we all know B is not greater than A. Let me say, let me give 10 for B. Now B, we all know that it's not greater than A, right? And then again, for else if, remember that I said that else if, and this is like saying if the previous condition were not true, then I try the next. And then in the next, it is not true again, you can see, because A is not equals to B. Now, once you reach at this point, then you have to use the else keyword, the else if keyword. Like you can say here, you can say now for else if you can say else, not else if, you just say else here, else, and then here you can say else, and then here let's say um, let's say print, let me say print B, sorry, should be, let me say B is smaller than A. So let me run these codes. And then you can see B is smaller than A because we said B is greater if B is greater than if B is greater than A, print B is greater than A, of which we know it is not greater than, so it will not print. And then for the next statement, it say if A equals to B, it will print out A and B are equals, and of course they are not equal, so it will omit this statement. Then for else, remember the else keyword, if other preceding conditions were not true, then for else it will print this statement here. So it say else B is smaller than A, and of course it's true. B is smaller than A. That's why it printed out B is smaller than A. So guys, basically that's how you can use those conditions. Now let me talk about the nested if. So you can also have the if statement inside the if statement. So basically in that case, that's what we call the nested if statement. Like, let me clear once again so that our codes may be kind of clean. And then here, let me say for example x, then let me assign it to something like 100, right? Then here let me say if, and then let me say for example if x is greater than 10, right? If x is greater than 10, we are gonna do what? Let's print use the braces, the curly braces, and then let me say print let me say print, and let me say print string here, and then let's say perhaps let me say above, let me say above 10, and then also I say that we can as well use another if inside another if, so it must be in the same curly braces. You can see it must be inside these curly braces, and then here again you can say you can as well say again inside this if, you can say if for example if x, for example if x is greater than if x is greater than let's say 20, you can say use the braces again, then you say above let's say, and also let's say print, and then here let me say, and of course it's a string, let me say and also, and also above above 20, and then if not, then let me also use another one. Inside this if, then let me say, for example, here let me say else. Let me say else print else print but not above 20. Let me say but it should be print function. First of all, let me say print, and then let me say but not above, what, above 20, above 20, right? But not above 20. And so so let me try to run and see if it will work out, or if we have the errors. So you can see here it is above 10, and also above 20. So guys, basically that's how you can use the the nested if statements, a statement inside another if condition. Let me talk about the and or operators. Guys, basically the and, we use this symbol. We use this symbol for and. We use this symbol for and. Is a logical operator and is used to combine conditional statements. Like, let me show you guys an example to test if a value is greater than, or something like that. Let me just say, for example, a. Let me assign to something like let me use the R ways of assigning a variable. It is this way. For example, it is 200. Remember, I'm used to Python. That's why most of the time I find myself confusing with the equal operators for basically the assignment operators for Python. Then here let's say B, and then let me assign it to for example 100 or 50. Then for C, let me assign it to something like, even let me say 300 or 400. Then let me use here an if. Let me say if for example a, if a is greater than B, and what, we use this anti-operator, this symbol, and see if a is greater than B and C, if a is greater than B and C is greater than let's say A greater than A, print, let me say print. First of all, it should be inside the braces, and then let's say print, let me say print, let me say print here, and then let me say both conditions are true. Both conditions are true. And then what I do, let me try to run and see if it will output something there at the time, and then you can see both conditions are true. And then of course you can add another condition, like for example the or. Basically you can also add another statement like else and so forth. However, let me talk about the or. Now basically for or, guys, we use the pipe. The pipe is the vertical line in your keyboard. This stuff is a vertical line to say or. This one is a logical operator and is used to combine a conditional statement. Like here I can say, for example, at least one of the condition is, let me do this. Let me say at least one of the condition is true. One of the condition is true. For example, if I say a is greater than B, and then for example, let me change this one to be the other way around. Like let's say a is greater than C, right? We all know that the first statement is true, right? A is greater than B, that is true. But the next statement is wrong, because A is not what? A is not greater than C, because C is 400. Now in this case, it will print out at least one of the condition is true. So basically this is how you can use the OR. So let me talk about another stuff here, and let me talk about the while loop. Let me talk about the while loop here. So basically the loops can execute a block of code as long as a specified condition is reached. Now basically the loops are handy because they save time and also reduce errors, and that they make code more readable. So R, just like in Python, it has two primitive commands, loop commands, that is while loops and the for loops. Now, R while loops, we can execute a set of statements as long as the condition is true. Like, let me show you. Let me say, for example, let me use an I, then let me assign it to something like 1. Let me assign it to something like 1. Then here, let me say while I is less than, perhaps less than, we use this operator, this stuff, and then so let's say like while I is less than, for example, 6. Let's print out something here, like let's say print let's say print I. Otherwise let's increment. Let's do this. Let's say I, it will be, let's assign it to +1, to an increment of 1. Oh guys, basically here I should have done what? Here I should have say I +1 so that it may increment by 1. So I forgot. That's why you can see our code just continue forever. Then let me select everything. Then first of all, guys, I have to break. How do I do that? Let me just let me stop. Yeah, guys, basically it's possible to stop. So guys, basically I forgot. Now guys, basically here I want to increment by 1 so it will reach 5, right? Let me run, and then you can see it has iterated to 5. So basically that's how you can do that. And then so basically the while loop requires relevant variables to be ready. So like in this example, we need to define an indexing variable that we used there. It was I, which we set to 1. Now guys, basically you also realize that our loop will just continue forever. So we have to use sometimes the break. So guys, basically with the break statement, you can stop the loop even if the while condition is true. Let me show you that. So let me show you that. For example, let me say if again. Let me use another if here. Then let me say if. Let me use if statement here. If I, for example, I is equals to 4. Then what I do, let me say break. Let me say break like this, and then what I do, let me just try to run and see if it will do it, if it will work out. And then let me run. So you can see it reaches to 3 because another stuffs. For the interest of time, let me talk about the for loop. But for loop, guys, I taught you earlier, but let me repeat. For example, let me say for x in this in a range of 1 to, perhaps let me use 10 so that it may not be long. Then let's iterate. Let's say print. Let's print what? Let's print the x. So it will print out 1 to 10. Let me select everything. Then let me run. Then you can see it has printed out from 1 to 10. So basically, this is less like the for keyword in other programming language, and works more like an iterator method as found in other object-oriented programming language. So with the for loop, we can execute a set of statements, once for each item in a vector, array, list, and so forth. So like Also, let's try with the let's try with the let's try with the with what? Let's try with the list here. So let's say fruits, perhaps fruits. And then let me assign it to some values like so for a list you have to define the list itself, like a list like this. Then here you can pass in your list, like let's say apple. Then let's say for example cherry should be cherry. And then what else? Let's say something like a banana, right? Banana. Then for x in fruits, in fruits variable. So it will iterate over this stuff. So let me just say let me just pass. Let me run. First of all, select everything. Then you run, and then you can see it has iterated over these stuff. So this of course you can also do them with the integers. For integers, let me just say like let me say 1 2 3 4 5 6 to infinity. Then when you run it will iterate over these steps. Guys, basically in this case I should have done what I should have. Let me use basically something like a dice to be. Let me change it to dice so that let me say dice here, and then here let me say dice. Let me say dice. Let me say dice, and then what I do here let's print out. Let's print the x, and then see if it will work out. When I run, you can see it has iterated over those stuff. So of course you can break. You can use the break in the next. But let me talk about the other thing here. Let me talk about the nested loops. The nested loops is, for example, let me just say, for example, let me use the same codes here. Let me use just these same codes, and then oh guys, let me just clear everything, then I begin. So let me begin with the adjacent add j, and then let me assign it to the list, and let me adjust here, add it to this list. And then here I can say for colors, let me use colors, for example red, and then let me say for example something like a big, and then the other one, let me use something another one like let me say test, tasty or a tasty. And then guys, here let me define a variable for fruits. Let me say fruits. Then let me use my fruits. Let me use my fruits here, and then I'm gonna pass in what? Let me pass in the list. Of course guys, you can use the tuple. Let me first of all, you can use the tuple and other integers, other data types, of course. And then here let me pass in perhaps apples, and then perhaps let me say bananas, and then of course you can use mango, of course, mango. And then now here guys, basically what I want to do here, let me say for example let me say let me use a for condition here. Let me say for x, basically for this stuff, let me just say for x in adj, that's adjacent that we used, the variable that we used there. Then here let me say for example I want to underscore the fact, the aspect of the nested, loops here. So here let me just say for example for x in this adjacent, let's say then let me say also for for y, let me use a different one. Let me say for y in fruits, for y in fruits, and then here now let me say let me concatenate, right? Let me just try to concatenate, and then let me say print a print function. Remember, when you use this condition, you have to use a print function, but inside this print function, we are going also to concatenate x and y, so to print out the values of the ADJ and the fruits. So let me try to run. I think my codes are okay, and then I guess basically you can see we have it has printed out these stuffs. So basically that's how you can work with the the nested stuff. Let me talk about the functions. Let me talk about the functions before we talk about the data structure. Now, a function is a block of code which only runs when it is called. So you can pass a data, basically known as parameters, into a function, and then a function can return data as a result. So let me show you guys how to create a function. Or now, to create a function, we use the function keyword. Let me do this. Let me first of all let me clear these other stuffs. Let me talk about this function. Let me show you that. So for example, let me say my function, right? Let me use this section. Let me say my underscore function, and then let me assign it to a function. Remember, to declare a function or to define a function, to create a function, you have to use this function. There's a function, and then here let's now this is the function that we have just created, and then this is the function itself that we use to create the function. And then here let's say something like let's say print print what? Let's say print something like let me just say name tag. Let me say name tag, and then what I do is here. So basically, this is how you can create a function, and of course now to call it. Remember, this way you can't execute this code at the terminal. Let me try to run and see if it will work out. I don't think so. It won't. You can see it won't work out. So you have to call it once you've created a function. You must call it for it to work. So our function name, it is my underscore function. So this way we have called it. Now when we run, it will be executed at the terminal of which is nametech. You can see it is nametech. So basically that's how you can do that. And of course, let me talk about the arguments. Now information can be passed into a function as arguments. Arguments are specified after a function name inside the parentheses, and you can add as many arguments as you want, and just separate them with a comma. If you don't, then it will throw an error. Now, for example, guys, let me show you an example here. Let me show you another example. Let me use this way, but inside this function, I'm gonna add in an argument. An argument, you add it here, like let's say f name, for example, f name first name, and then here I'll say let me concatenate. For example, let me concatenate, and then let me say to concatenate to use the paste function. And then here I'm gonna say, for example, f name, and then comma, then perhaps I say that we use a comma to separate, and then for example, let me say Nehemiah. Let me use Nehemiah, and then let me just say Wekesa, right? Let me say Wekesa because it's gonna be the last name. And then here now to the call function, let me first of all copy, and then perhaps let me try to pass several, like 3. Then the first one, like I can say Nehemiah. Then the second one can be John. The third one can be Mercy. And then now guys, basically when you run, it will be Nehemiah Wekesa, John Wekesa, Mas Wekesa, and so forth. So guys, basically you can see now the outputs here. And so basically that's how you can work with those stuffs. So guys, let me talk about another thing here. Let me talk about the nested function. Remember, nested function is a function inside another function. So basically, there are two ways to create a nested function: to call a function with another function, and another option is to write a function within a function. And now let's begin by calling a function within another function. Like let's, for example, here let me just say let me clear these stuffs, and then for example let me clear everything guys, so that, or let me just clear this stuff so that we may be on the same page, so that everyone can understand. So for example, here of course I can pass in now, instead of fname, let me pass in something like x and y. And then here I can say something like for example, if a, let me assign a to perhaps x plus plus something like y, that's such stuff. Then let me say return what is gonna return a. And then now here let me create another function. So let me say for example, let me say nested function. Let me say nested. Let me create another function called nested function. Nested function. What's the spelling for function? It is this way, right? Nested function. Then inside this nested function here, guys, I'll pass also another function. Let me first of all call it. Let me say nested underscore function. Nested function. Then here perhaps I can say 2. And then 2, so it will be x will be 2, y will be 2, so it will be 4. Then also I want to do what I want to add in another one. Let me add in another one, like let me say nested function. Nested function. Then here let me pass in 3, perhaps 3 plus 3 plus 3 plus 3, right? 3 plus 3. And then what I do, let me just try to run. So it will be, this one is 4. Then this other one is this other one is oh, of course guys, here I should have also changed it to nested. Let me say nested function, because we are calling a function inside a function. So here it will be 2 plus 2, that is 4. Then this one is 6. So 4 plus what? 4 plus 6 plus 6, it will be 10, right? Let me run and see if it will work out, or it will throw an error. Then again, you can see it is, it is 10. That's how you can work with the nested nested functions. So let me talk about the function recursion, and of course R also accepts the function recursion, which means a defined function can call itself. Now recursion is a common mathematical and a programming concept. It means that a function can call itself. So these are the benefits of, meaning that you can loop through a data to reach your results. So the developer should be very careful with the recursion, as it can be quite easy to slip into writing a function which never terminates, or one that uses an excessive amount of memory, or processes power. So guys, basically when you write it correctly, then a recursion can be very efficient and a mathematically elegant approach to programming. So perhaps guys, let me just show you an example. An example guys of recursion here. So let me just call it, perhaps let me say try underscore a recursion, try underscore recursion, and then let me assign it to a function, and then this function let me use a k perhaps. Then let me assign it to, let me actually pass in, let me use an if condition here. Let me say if k should be inside the parentheses. If k, let me say if k here is greater than, let's say 0, then here what I do, let me say result, result should be a result. I'll assign it to k plus the try recursion. Let me just copy this stuff because I'm not sure with my spellings. Try recursion, then here I'll pass in k perhaps -1, and then here let's say print. Basically, let me say what? Let me say here let me say print. I'll print what? I'll print the result. I'll print results. Otherwise, so let me say else. I'll print what? I'll print I'll print the results. Result will be 0. Let me give it 0, and then I'll return what? I'll return a result, and then of course here let's call the function. I said that once you've declared a variable, once you've created your function, you have to call it. So it's try recursion. Let me just copy it. Let me paste it here. Try recursion. Then here let's give it perhaps something like a 6. And then what I do, let me try to run. Let me select all, and then let me run. And then guys, basically you can see it has given you this result. So this is all about the R functions. So guys, I want us to advance. I want us to talk about the data structure. Under it, we shall talk about the vectors, list, matrices, arrays, data frames, and also the factors. So let's begin with the vectors, and perhaps let me try to clear these codes, and then also let me clear these stuffs, so that we may focus on a clean workspace. Now guys, basically let's begin with the vectors. A vector is simply a list of items that are of the same type. Now to combine the list of items to a vector, we use the C function and separate the items by a comma inside that function. So basically I want to show you an example here. For example, let me have I like using fruits, right? Let me use fruits, and then sorry guys, you can write it at the console. However, I want to, let me just type here because it's a good practice to use it here. And then here guys, I'm gonna type in, let me type in a fruits, then let me assign it. Remember to assign, we use the angle bracket for less than, and then we are gonna assign it to, I say that we use this as a function to define a vector, and then in this one I'm gonna pass in a list of items. Basically, some items here, like I can give it even banana. Let me give it also something like another fruit like apple, and then the other fruit I can give it even let me use orange perhaps, or any other fruit, orange. Guys, I'm not limiting you to use your preferred items, but for the sake of tutorial, I'm sticking to these ones because these are the ones that I used on the website. Now to print it out, to print these are fruits, we are gonna just type in a fruits, and then it's gonna be printed out. So let me run and see. You can see it has printed out these items. These are fruits. So in this example, guys, we have created a vector that combines numeric Basically in this that combines the strings in this case. Of course, you can as well use the numeric, like numeric. They are the values, the whole numbers, like 1, 2, 3, 4, even 5.5. These are kind of numeric values, but in this case, guys, I'll have to change. Let me change here to, let me give it numbers. Let me give it numbers, right? And then we run what the numbers, and then let's run and see if it will work out. You can see it also work with the numbers. Now, so we can as well create a vector with the numeric values in a sequence. So like in that case, guys, you have to separate with a comma. For example, if it's between a certain value to a certain value, you separate with a comma. So like, let me show you that. So in that case, guys, you just specify the range. For example, 1, 2. For example, 1 to 10, it will print out from 1. It will iterate 1 through 10. So it will be 1 to 10. Then what I do, let me just let me run. Let me run and see. You can see, guys, it has iterated, it has printed out those values here. And so you can create numeric values with the decimals in a sequence, but note that if the last element does not belong to the sequence, it is not used. Like for example, if you say this one will be outputted, this one will include the last item. Like if I say 1.5, it will be included. Then this one, let me use a smaller items, like even 6. Let me say 6.5. In this case, guys, the last item will be included in the list. 6.5, right? Let me remember, you separate with what here should be not a comma, should be a full stop, like a dot. Then you can see in this case it is 1.5 through 6.5, but if you use a different item, basically a different if you use a number or an element which does not belong to the sequence, it will not be used. Like if I say a 6.2, it will not print out 6.2, it will print out 1.5 through 5.5. Let me run and see how it will be. You can see it is through 1.5. It has not printed out this 6.2 because it's not in the sequence. Now, also we can create a vector, with the logical values. Remember, our logical values, it is either true, false values. Like you can say C to define your vector, and then here let's say true. Remember, it should be in capital. True, false, and then perhaps true again, and the list continues. So in that case, guys, here let me just call it logical, right? Control, sorry. Let me just, in Visual Studio Code, you can just do, select several items by clicking on Control plus D. But in this text editor, it doesn't work like that. So you have just to change everything manually. Like here, you can say logicals. Let me just call it sorry, should be logical. Logical like this. And then also here you have to pass in logicals, logical like that. And then what I do, basically logical, it should be logical with that. Do you remember this one is a variable? And then let me run. It will be outputted. It will print out those logical values. And to obtain the length of a vector, we use the length function. Like for example, if I want to obtain the length here, you just say length let me say you use length. This is not the spelling for length. I think it is this way, right? Length. Then inside it you pass in your variable like a logical this is a logical here. Then let's run and see if it will output the results. You can see it is 3. Of course, if you add several, it will print out several of those items. Like for example, if we say again true, it will print out it will be 4. So let's run and see. You can see now it is 4. So basically that's how you can do that. Of course you can as well sort your vector. To sort items in alphabetical or a numerical, we use the sort. So like we all know that T and F begins, then F basically T follows. So in that case, gives you just say, for example, if it is these are fruits, these are logical, just say sort. Remember, this one is case sensitive, so you use the small letter. Then it will be at the print function at the terminal, it will begin with the false, then a true, true, true. So let me run. Then you can see it has begun with the false, true, true. Of course, you can do the same with the numbers. Numbers, you just say, for example, let me just say numbers. Then let me assign it to some numbers here, like we use C to define your vector, and then perhaps let's say 1, 2, 3, 4, 5, and then here let me just say something like 12, and then 6, then 11. So it will sort it. It will sort it in an ordered sequence. So it will sort numbers from 1, 2, 3 in that format. Like if we just say sort, and then we are passing out numbers. Then when we run, let's run and see. You can see it is now 1, 2, 3, 4, 5, 6, 11, 23. So it has gone in an ordered sequence. And of course, guys, you can as well access each element. And guys, basically, for example, if I want to access, let me just rewrite here. Let me use fruits, and then let me assign it to my fruits. We use I'm used to Python, but in R we use these stuff to assign some value. Of course, it accepts also the equal operator, but in some cases it might fail. However, it is a good practice to use this assignment stuff for R. Now here I'm gonna pass in C, then I pass in my fruits. Like for example, if it's banana, I just say banana, and then if it's apple, I just say apple, and then if it's what, which fruits do you like? I like also mango. So basically this is our vector, and then now guys are basically if I want to access some item here, like if I want to access the first fruit, so fruit should be fruits, right? If I want to access the first item, you just say 1, and then when you run, it will print out only the first item, and then you can see it is banana. Like unlike in Python, where indexing begins from 0, here indexing begins from 1. So 1 it is banana. So basically that's how you can access. And of course you can choose also to access the perhaps some certain number of items that you want. For example, if you want to access perhaps only banana and mango in this list, in this vector, what you do, just pass here C, you are C up here, and then here you specify the items that you want. For example, if it's 1 and then 3, so it will print out a banana and a fruit. So let's try to run and see. And correct number of dimension, right? 1 and okay, so basically here it shouldn't be the squared bracket should be the rounded brackets here, like this. Then what I do, let me run and see if it will work out. Yeah, you can see now it has printed out banana and and the mangoes. And so okay, so basically this is, I think, about the this is all about. Of course, you can also generate sequenced vectors. You can also repeat the sequences. You can change an item and so forth. You can find the reference on the website. But guys, I want to focus on the very important aspects here. So let me just go to the next item. Let me talk about the list. Now, a list in R can contain many different data types inside it. A list is a collection of data which is ordered and changeable. So to create a list, we use the list function. So like if one to if one remember C is for vectors, and then a list we use else list like this. Then you pass in your list like this. Remember in Python, list is defined using the these are the squared what these are squared brackets, but here you just define it list. You just say list, then it will be list. Then for example, let me just call it the list, right? Let me say call it the list, and then here let me just pass in the list. So let me print out, let me run it, and then I guess you can see it is it is the list. It is the list now here. So the same principle applies here also with the list. To access an item, we just specify with these squared brackets, pair of squared brackets opening and closing. Then if it's one, just say one. Then when you run, you'll obtain the first item in the list, of which is a banana. So basically, perhaps let me just show you how you can change how you can change the item. To change the item of a specific item. Basically, to change the value of a specific item, you refer to the index number. Like, for example, let me just let me just say this is a list. Then I specify the item that you want to change. Perhaps if it's the first item, banana, you want to change it to something else. Then you have to use this assignment stuff, and then here you specify the item that you want to replace there. For example, if it's orange, let me use orange, and then let's print out the updated list. Perhaps let me use a comment because I showed you how to use comments. Let me see the updated list. Remember, the comments won't be executed at the terminal. So let me say print out the list. Let me just run, and then you can see now in the console it has updated to orange, apple, and mango. So guys, basically you can see how you can do that. Now for length guys, the same principle applies. You just say length, then you specify the your variable or your object, then you'll obtain that. However, let me talk about another item. Perhaps guys, let me just be in detail so that you can understand every concept here. So let me show you how you can add an item. To add an item, we use the append method or append function. So let me just say, for example, let me just delete these tabs. So guys, this you can see this is our original list. Now I want us to append. To append, I say that I will use the append function. Then in this append function, you first of all specify your variable, your object, the list, then separate with a comma. Then to append, guys, for example, if you want to add in orange, you just say orange. Then when you run it will be appended. You can see now orange is added. To remove an item, we just use the negative operator. For example, if you say sorry, let me just delete this task, and then here let me just say perhaps new list, and then I'll assign it to perhaps you specify first of all the variable, the initial variable of which it was the list, and then in the list, so you target the item that you want to remove. For example, if it's one, the first item, it will say -1, then it will remove the first item. So let's try to print out and say the list. Basically, it should be new list, right? It should be new new list like this. So let's run and see. So new list not found, right? Oh, here I forgot it should be W somewhere. So let me try to run again and see. So you can see now the first item is removed. It is now apple and a mango. So of course, if you want the second item, you can just say 2. Then it will delete the second item, and then it will print out banana and a mango, of which they are the first and the last, the third item. So so guys, basically, of course, to range guys, you can also range the indices. However, guys, don't want to go through that. Of course, you can also loop. We talked about the loops to join. To join, you know how to join. I showed you earlier, but you just separate with a comma, and then you can join those items. You can concatenate. Let me talk about the matrices. Now, a matrix is a two-dimensional data set with the columns and rows. So a column is a vertical representation of data. You know this stuff. While a row is a horizontal representation of data. Now, a matrix can be created with the matrix function, and then you specify the n row and n column or n call parameters to get the amount of rows and columns. Like, let me show you an example of how you can create a matrix. So, for example, let me just say my matrix. You can use any other variable name. Then, let me assign it to matrix. I said that to define a matrix, you use the matrix function, and then in this matrix, perhaps let me use a vector inside it. So I'd say C. Remember, vector is defined with the C. And then here in this vector, I'm gonna pass in perhaps some values like 1, 2, 3, 4, 5, 6, and so forth. And then now here, let me just say n row, number of row, n row. I can give it even, let me assign it to, let me give it 3 perhaps. And then the number of column, n col, I can give it even 2 columns. So it will have 2 columns and 3 rows. So, and then now guys, to execute the codes there, the console, or to be printed out, we just say my matrix like that. Then let's run and see. So guys, you can see now we have now this matrix here where we have 2 columns and 3 rows. So you can see even it shows you the counters. So you can see we have the this is 1, 2, then for row 1, 2, 3. So guys, remember the C function is used to concatenate items together. The C, that one for vectors. For vectors. Now, guys, how do you access the matrix? Guys, to access that matrix, you have to use the squared bracket, the pair of opening and closing of square brackets. The first number in the bracket specify the row position, while the second number will specify the column position. Like for example, here let me just say so here let me pass in these square brackets. Then for example, if you say 1, this one will show that this one will specify what the row position, so it will be row 1 for example. And then now the column 2, for example, if I specify 2, it will be what, it will be 4. It will output 4 for the execution here at the terminal. So let me run and see. So guys, you can see it is 4. If it were 3, if it were row 2, it will be what? It will be 2, right? It will be 4, 5, 5, 5, 5. Yeah, let me run, and so we can see it is it is 5. So guys, basically that's how you can do with that. And of course, to access a matrix, you know how to access them. Basically, to access multiple. Let me show you guys that. For example, if you want to access more than one row, you have to use the C function. You have to use the C function if you want to access more than one row. So basically should I show you that? Of course, guys, I think you understand these steps. Let me just go to another item for the sake of for the interest of time. So, of course, guys, the reference is on the website. I want just to tackle the hard things so that you may get the concept so that you can apply other stuffs on your end. Let me talk about the arrays. Now, arrays, basically to compare matrices, arrays can have more than, two dimensions. We can use the array function to create an array and dim parameter to specify the number of, basically the dimensions. Like, let me create an array, like, let me say my array, let me just call it my array. Then I'm gonna assign it to the array, and of course we use C function here, then a 1, and then a 2. Perhaps let me use a 24. Let me just use 24 here, and then of course let me just execute. So basically this one will execute. If I run my array, it will execute values ranging from 1 to 24 all the way to 24, 1 2 3 to 24. So but also I want to do what I want to create another one. Let me call it multi. Let me call it multi array. Let me just call it multi. What is spelling for multi array? Multi array. Then to assign, we use this angle bracket for less than, and then the hyphens, and then we use the array for multi array. Array function here, and then you can pass in, for example, this basically my array, the first array, the array, and then also basically I say that I'll use the dim parameter to specify the dimensions, like let's say dim, then in this dim I can pass in, I can use C, and then I can specify, for example, 4, and then let me say 3, and then let me say 2. So guys, basically in this case, the first and second number in the bracket specify the amount of row in the columns. So it will be 4 rows, 3 columns, and then basically the last number here 2. This last number here specify how many dimension that we want. So in our case we want 2 dimensions. So so now to print out, to execute, we'll say multi array. So let me just say multi array, and then what I do, let me run and see. And so guys, basically you can see it is working. You can see it is just like we did here. It is 4 rows. I said the first item specified the rows, of which you have 4 rows. Then the second item has 3 rows, and then the third item, it says that it help us to identify how many number of dimensions. So guys, basically that's how you can do that. And of course, to access an array, guys, you just basically to access array items, you just specify. I think you understand this stuff. However, let me just show you. For example, if it's 2, 3, for example, 2 again, you can as well do this to access an array. Then let me run, and then you can see, guys, it is 20. It is 22. So guys, basically this is how you can work with that. So guys, basically the array length, if you want to obtain the array length, you just do what, you just use the length parameter. So let me just say length, then here you can pass in your, let's say, let me use multi, should be multi array, and then I think it should be 24, right? I'm not sure. Let me just run. You can see now it is 24, and then so guys, basically I think this is all about the arrays. Of course, you have other, you can play around with the arrays, like you can even use the loops, you can even loop your arrays, you can do many other stuffs with the arrays. However, I want to go to the next item. Let me talk about what should I talk about? Let me talk about the data frames. So guys, let me now talk about the data frames. And data frames are data displayed in a format as a table. So data frames can have different types of data inside it. While basically the first column can be perhaps something like a string. You can have a column, for example, for names of people, and then the second item can be numeric, like for example the age of those people. Then the third one can be even the logical, like a true, false, and so forth. So each column can have, uh, basically each column should have, the same type of data. So if you have a column for example, string, for example, name of people, so that column should be strictly for, the string of order for characters. So let me just have something here. Let me just create some data frame. Let me just call it data underscore frame frame data underscore frame. And then here let me assign it to uh, data dot frame should be dot frame. Let me use frame the data dot frame. Then here guys, perhaps the first column, let me call it perhaps let me call it perhaps let me use sport activity. So the first column will be, let me call it training. Let me just call it training. Training, the first column. Then in this training, I can assign it to this function here, and then call it, for example, the first item. Let me call it strength. Let me call it strength. What is spelling for strength? I think it is this way, strength. And then for example the second one, let me call it something like stamina. Then the third one, let me call it perhaps other. So guys, basically you realize that in this column everything is what is a string, so you can't mix. So it's either everything a string. If it's integers, should be all, everything should be integers. So let me add in another one, like first of all, perhaps let me try to add in here another one, like let me call it the other one for pulse, the other column for pulse. Pulse. Then in these are pulse, I can assign it to perhaps C. Then I can pass in some values. Remember, if it's integer, should be just integers, like 100 pass rate 100, and then 150, and then perhaps 120. Let me give it 120. 120. I don't know the maximum pass rate should be what. However, let me just say perhaps duration duration for the exercise, perhaps duration for training, perhaps let me assign it to remember we use this C to join something, to join stuffs. For example, if it's 60, the first item, then the second item should be, for example, let's say 30 minutes. Then the other one, let's say something like a 45. So basically this is an example of our data frame, and to execute, we just run this variable here. We just run this variable here, then it will print out the data frame. So let me run and see if it's true. Guys, basically it has thrown an error. So guys, basically we should have separated these arguments with a comma. That's very important. So guys, basically we should do this. Then let me try to run again and see if it will still bring an error, or we have sorted it out. Yeah, guys, you can see it does. So you can see we have now our data frame with the training, pass, and the duration. We have 3 columns, and you can see in each column there are unique data types. Like for example, this one is characters or strings. All of them are strings. If it's integer, all of them are integers, and so forth. Uh, so um, so guys, basically, how can we summarize the data? So guys, basically, there's a function to summarize the data, which is called summary function, which will summarize the data frame. Basically, the data from from the frame. So, like, if I want to summarize, let me just show you. Just say summary, summary function, and then here you pass in your data underscore frame, data underscore frame object. Then let me run and see if it will summarize for us. Then guys, you can see it does. So so guys, basically you can see how it does. So now how can we access an item? To access an item, guys, you just do what you just specify. Basically, you can use single brackets or double brackets or even the AND to access columns from a data frame. Like for example, let me delete this tabs here, right? Let me just say delete, and then here guys, let me say what. Let me just, for example, if I want to access the first item, I can just say want to access the first, the first column. It will be this way. Let me run and see if it's true. Guys, you can see we have obtained the first column. Of course, if I want to specify the second, to obtain the second column, just say 2. Then when you run, it will be the second column. Of course, guys, I see that you can as well use what you can as well use the names. Like for example, if you want to specify the column name, you have to use the double quotes. And then you pass in your title. Like if it's training, it will print out the training column. So guys, you can see it has printed out the content for the training. And of course, you can say the other way to obtain the column values, you can just say data frames. Then I will use the and operator. And then for example, if it's training, then when you run, it will obtain that column, the values of that column. Training is not obtained, is not training not found. What's the problem? I don't know what's the problem. Training. I think it should be available. I don't know. Not really, guys. We don't use this and we use the dollar sign, not the and. We use the dollar sign. Let's try with the dollar sign. I think this one should work. Let me run. Yeah, guys, you can see it does. Yeah. So it's not and, it is the dollar sign. So of course, guys, you can add the row. You can basically add the rows basically we use the row bind function to add a new row. Basically, R bind function to add a new rows in a data frame. Like, let me show you. If you want to add in another row, you just say what you just say. Let me call it a function. Like, let me just say new. Let me give it a variable new data frame, df, new data frame, and then let me assign it to cbind. I say that we use the cbind function, and then inside this cbind function, just specify first of all the variable that you want to extend or to add the row, which is data frame. And then you also do what you say a comma. You say comma first of all, and then you do what you pass in the steps. You say steps. I say step. I say steps, and then perhaps if you want to basically I'm using the steps, but you can do it. You can use anything else. Like you can say even calorie burnage and such stuff, and but let me just use steps. And then let me assign it to C. Remember, we use the C function if you want to join items together, like to create your vector. So here I can say, for example, 60 steps, 30 steps. Let me just let it be 1000. Let me use 1000 steps, and then 600, perhaps 600 steps, 6000, then perhaps 2000 steps, and then here let's print out now our new what our new df. Then what I do, let me run and see if it will so guys, you can see now we have the column for what we have another section for steps. So basically that's how you can do that. And of course, to remove you can as well remove the columns. Now to remove to remove guys, we just say for example, if it's df, and then you assign it to, you just say data frame. Perhaps let me just do it. Let me just use this new df. Then let me delete these tabs, and then let me assign it. Let me assign it to data frame. And then here I'm gonna pass in what I'm gonna pass in negative. Perhaps I'm gonna pass in negative. Then I use now C, and then you do what, you pass the first argument that you want to remove, and then also you do what, you can specify twice. For example, if you want to target twice, and then for example, if it's negative C, negative C, then I specify the item that you are targeting. For example, if it's if it's one, if you want to remove this, then you just specify that. And then what you do, let's print now the new df, and it will do what, it will remove rows and columns. So this one is it will remove the first row and the first column. So let me just run this stuff. Then when you run, you can see now we don't have those other, basically row 1 and column 1. So basically that's how you can do that. And yeah, so guys, I think now you have understood that. So let me talk about the factors. You can find more details about the data frames on the website, but let me talk about the factors. Now, factors are used to categorize data. For example, factors can be demography, that is male and female. Music can be rock, pop, classic, jazz, and so forth. Training, for example, can be strength, stamina, and so forth. Now, to create a factor, we use the factor function and add a vector as an argument. So, for example, let me just show you an example. Like, let me say music gene. Music gene, then let me assign it to factor function, factor like this, factor function. Then here guys, you have to do what, you have to pass in through the vector as an argument. So our vector is c, and then we pass in what, we pass in our items. So for example, the first item can be jazz, for example, and then for example, let's say rock, and then the other one, let it be classic, and then the other one can be, let me also use classic again, let me say classic. Then the other one can be even, let me use a pop once again. Remember, everything is a string here, so let me say pop. And then and then the other one can be, let me use jazz again. The string should be a string. Then let me say jazz. Then the other one can be, again, let me repeat, rock. Then perhaps let this stuff to be enough. And then here the print function, I can say what, here let me just say music gene. Let me copy it, then let me paste it here. Then when you execute, when you run, it will print out your items here. Also, you can see it has printed out basically the items here, and then also it has printed out the levels here. So you can see from this example that the factor has 4 levels or categories. That is classic. That is what? That is classic, jazz, pop, and rock. So basically, these are the items, and uh, basically, if I want to print only the levels, you just use the level function. Then you pass in what? You pass in your variable or your object. So just say level. If I want to obtain only the level, just say level, and you pass in what? You pass in the object here. So it should be levels, not level. Levels like this. Then when you run, you'll obtain only the values for the levels, like it's jazz, a classic, pop, and rock. So guys, the other thing that I want us to talk about here is the R graphics, and of course under it we shall talk about the plots, including the lines, scatter plot, pie charts, and bars. Now perhaps let me try to zoom out a bit. So because we are gonna use this panel here, these are plots panel. Let me zoom out. Should be, is it zoom in? Should be. I think I should do this. Let me just how can I extend this stuff so that it can be quite visible? Well, let me just how can I transfer this panel to be here? So this one, let me just minimize. Let me just minimize, and then let me focus on this segment here, and of course let me minimize this section so that I may have only this part. Now guys, basically how do we plot? How do we plot in R? So basically the plot function is used to draw points or basically points or markers in a diagram. Now the function takes parameters for specifying points on the diagram, like a parameter 1 specify the points on the x-axis, then a parameter 2 specify the points on the y-axis. Now it is simplest, basically it is simplest, you can use the plot function, and then to plot basically two numbers against each other, like let me just, in this case, let me just say, for example, plot here, let me just say plot, for example, let me say plot 2 versus 4, and then or 2 versus 4, then let me just run. So this is the shortcut to run, right? And then I guess you can see it has printed out these stuffs here, and then let me try to minimize this section here so that it cannot bring a lot of issues. So guys, basically this is how you can draw one point in the diagram at position 2 and position 4. So so for example, if you want to draw 2 points in the diagram, one at position perhaps position whatever and whatever, you have to use the C function to join them. Now here you'll say what to define actually 2 coordinates. You'll use basically the first C to join 2 items. For example, if it's coordinate, for example 1 8, and then the second is separate with a comma, the parameters with a comma. Then at the second C here you specify the second coordinate can be 3 and 3 and what is that 10. Then it will do it when you run, it will be 2 points. You can see now you have C3 10, and then C1 8. So guys, basically that's how you can obtain. And of course for multiple points you can just specify, you just add the number of points that you want. For example, if it's so I think I should maximize on this section. Then how do I extend these stuff? Let me try to zoom out a bit. Let me try to zoom out so that you can see much better. So yeah, I think as you can see, I don't know if you can see better. Let me try to zoom in a bit. Yeah, so guys, for example, if you want to add several items, you can just say 1, then a 2, 3, 4, 5, for example, up to 5. Then for the second parameters here, you can just say, for example, 3, 7, 8. Remember the numbers should be equal. 9 perhaps, and then for example, even 12. 1 2 3 4 5. 1 2 3 4 5. Yeah, there are 5. So when you run, it will print out these stuff here. You can see now we have these are 6. Basically these 5 items here, and it's kind of a what curve kind of plot. So that's how it will look like. Now for better organization, guys, you have to, it's a good practice to separate, to use or basically to use variables. So like you can say, for example, it's a good practice to use variables. Like for example, if it is C, you can just say x, then you assign it to. Remember assignment operator here, we use the angle of less than, followed by with the hyphens. Now for the second item, I can just say for example, let me call it y-axis, then let me assign it to this stuff, and then of course here it shouldn't be 2, can be just 1 like that. And then now to plot, just say plot, and then you plot x and y. You plot x, should be x and y. So the first argument represents the x-axis, the second one y-axis. Then when you run, guys, you can see it gives you the same result. So basically this is a good way, other than printing out see whatever. So basically this is how you can do that. Now for example, if you have a sequence, you want to draw dots in a sequence on both x and y axis. Now we have to use what? We use the colons operator. Like for example, if you want to say plot, for example, if you want to plot for example a range of 1 to 10, so you separate with a colon like that, then it will print this as you can see. Now we have 10 points like this. So guys, basically that's how you can do that. And how do you draw a line? Now guys, basically to draw a line you have to add in the type function. The plot function also takes the type parameter with the L to draw a line to connect all the points on the diagram. So like let me show you that. So first of all, separate with a comma here, and then here you just say a type, and then you say L if you want it to be a line. Then when you run, it will have a line. You can see now it has now the lines. Now for labels, for example, if you want to label x and y, instead of using these stuffs here, you can do it. You can add in another parameter here, like for example, you can even give it the head. So like in a nutshell, guys, this plot function also accepts parameters such as main, lab, label, or x lab, and a y lab if you want to customize the graph with the main title and a different labels for x and y axis. So like in this case, guys, I want to do this. Let me just here. For example, if I want to add the main title, you just say main, it will be the main title, and then you specify, like let me say my graph like this. And then for x label, use first of all separate with the comma, then we say x lab like this. Then you can say, let me just say, give it perhaps, let me call it x-axis. Should be inside the string because it's a string. Like let me say x-axis, and then of course I can add in another one here. Let me just copy and then a comma, and then let me paste it there. Then here I can call it let me call it to y. Then let me call it here, sorry, let me call it, should be y, right? and then here should be y-axis. So let me run and see if it will output such a stuff. You can see now we have the y-axis, the x-axis, and then we have the main title. Here it is, my graph. So basically that's how you can do that, and of course you can add other parameters like the colors. For example, if you want to add the color, use the C or L. Another parameter here can be colors. Like first of all, separate the comma like for color, just say C or L. Then you assign it to your color, like can be color can be, you just say C or L. Then you assign it to perhaps if it's red, let me just use red like that. Let me say red. Then when you run, I think it should be red here. You can see it's red, though I'm not sure if you can see it, but I think on my end it is visible. So it is red. Now, for example, if you want to specify let's say, for example, if you want to specify the size, you can just use the CEX, then you assign it to your values. Like if it's 3, then when you run, it will be increased. Here now you can see they are big. So of course you can also point the shape. For example, if you want to use okay, so basically use the PCH with a value from 0 to 25 to change the point of the shape. Like for example, let's add in that argument. Let's say PCH, basically PCH. Then you can assign it to your value. Like even if you give it 25, it will be kind of a rectangle, right? Because it's the highest. Let's 25. Then let's run. Then I guess you can see it's kind of a triangle. It's a triangle, right? Now so guys, basically in a nutshell, 0 it will be a rectangle, then a 1 will be kind of a hexadecimal kind of stuff, 2 it will be 2 will be triangle, and then 3 will be across. Let me just show you guys other than talking much. Let me just show you. Then when you run, you can see now the shape have changed. If it's 13 or 23, let me use 23, then it will be this kind of a stuff. So you can play around those values provided it's at the range of 0 and 25. Now guys, basically I want to talk about the lines. Now guys, I showed you earlier that to add the line we use the type parameter with the values, with the value L. Like for example, I don't know if I am confusing you, but here, or let it be here at the start and this at the end. So here I can just say what? Let me just say type, and then you assign it to the L if you want a line. So you just say L, and then it should be a string, right? Then of course you separate arguments with the comma, and then so in this case when you run, it will be a line. It will have a line. Then I guess you can see now we have the line, and the line is red. Of course, guys, when you use the line, you won't need to have this PCH value here, and then you won't need also to have this stuff here. So let it be the way it is, like that. And then now guys, basically also the line color, you just specify C or L. For example, if you want blue, just say blue, then when you run, it will be what? It will be blue. Now you can see it's blue. I don't know if you can see, but on my end it's blue. Now the line width, you just say L width. First of all, let me use here, and then here let me just say L W the L width. Then you can assign it to your value, like if it's 2 pixel or 2 points, just say 2. And then for example, when you run, it will be kind of big. If you use 3, it will be 3 thickness, 3 pixel, such stuff. So then of course you can have the line style, like I can even now guys, let me talk about the line styles. The lines is solid by default, but you can as well use the LTY for line style parameter with the value between 0 to 6 to specify the line format. For example, LTY3 will be displayed as a dotted line instead of a solid line. Let me show you that, guys. So first of all, here I can say what I can say. For example, LTY, then I can assign it to, I say that a 3 it will be a dotted, right? So 3 will be a dotted. Let me run and see if it's true. Yeah, guys, you can see now it is kind of, dotted line. Let's try with 4 and see what it will output. You can see, for example, if it's 2, what will it bring? Yeah, so guys, basically can play around with those stuffs. And so in a nutshell, guys, 0 removes the line, and then 1 display a solid line. 1 will display a solid line. If I were to run 1, it will display a solid line. And then 0 will remove the line completely. You won't see the line there. And then basically 3 is a dotted line, as I showed you earlier. 4 display a dashed, basically a dot dashed. 4, let me just show you that. 4, it will be it will be dot dashed, and then 5 it will be a long dashed. You can see it's a long dashed, and then 6 will be a 2 dashed line, like let's say 6. Then this one will be 2 dashed line. Now guys, basically how do you output the different lines or multiple lines? Now to display more than one line in a graph, we use the plot function together with the lines function. So let me show you an example. Perhaps let me just delete this stuff, and I want to use the variable, like let me just say line 1. Then I can assign it to these values. Remember, we use the C to join values or to vector values. I can say 1, perhaps 2, 3, 4, 5. Perhaps let me also add in 10. Perhaps let me say 10. And then the second line, it will be line 2. Line 2, I can assign it to these values. Perhaps let me call it 2, 5, 7, and then what else? 8 and 9 and 10. Remember, they must be equal, right? So not really equal, but it should be that way. Then guys, basically if you want to use 2 lines, then you have to use the plot function, and then the line function inside it, and then you just pass in, for example, line 1, for example, and then you specify the type, the line type, the type you assign it to a type, so it should be L, right? L to show that it's a line, and then you can give it a color. You can specify the color or leave it the way it is, color, COL. Then you can assign it to a color, like if it's blue, I can say just say blue. And then for example, I can add in the second line. Let me copy, and then here let me just pass there. And then this one, let me call it red. Let me use color red. Then of course I can change here to line 2 instead of line 1. So let me say line 2. And then what I do, let me run and see if it will print out 2 lines. So guys, you can see in this case it has not printed out the blue one, because in this second argument we should have used the lines parameters, like lines here. And then when we run guys, it should print out case. So guys, you can see now we have two values, two lines here, the red and the blue one here. So guys, basically this is all about the lines. I think you have understood the aspect, the concept here. So guys, let me now talk about the scatter plot, and we have just talked about the plot function in a few, that it is used to plot numbers against each others. Now a scatter plot is a type of plot used to display a relationship between two numerical variables and plots one dot for each observations. Now it needs two vectors of the same length, that is for the x-axis and for the y-axis. Like for example, let me just use these values. You can see they are equal values. So I can do this. I can do this. I can just use the same values. Perhaps let me say plot, and then here I can plot the. Let me just use x. Then here let me use y. Then so let me pass in x and y. So when I run, it will print a scatter plot of x and y values, and you can see here the values. So basically, this is how you can do that, and of course, you can have a very large number of data so that you may compare your plots. So guys, basically this is all about this cut. I don't think there's much to explore here. However, you can find the reference on the website. I think I have a profound stuff on the theme. However, let me talk about the pie charts. Now guys, basically a pie chart is a circular graphical view of data. So we use the pie function to draw the pie charts. So like let me create some values for our pie charts. Let me delete these stuff, and then let me say let me create x, and then let me assign it to this. Let me assign it to these values. So of course, we use the angle bracket for less than and the hyphen to show the assignment operator here, and then C to join our vectors. Perhaps let me say 10, 20, 30, and perhaps 40. Now here let me say pi. Let me use pi. Let me use pi function. Let me say pi. And then I'm passing what x. Let me try to explain in a few how it will be outputted. So basically the pi will be, for example, the ratio of 10. It will be 10 over the summation of this number times 360. So the portion for 10 it will be a bit small, 20 will be large, and then a 40 will be the highest. So let me try to run and see if it will print out, and then I guess you can see this is 1, 2, 3, 4. Basically it goes on counterclockwise. Now this one is for 10, this one is for 20, then a 40 you can see it is big. So basically what it does, it took the for example, if it's 40, it will be 40 over the summation of all these stuffs here times 360, because this circle or a circular stuff is 360. So basically that's how it will look like. Now you can also change the start angle by adding another parameter here called INIT, or initialize INT angle. Angle basically should be not really should be dot, and then angle, and then you specify the start angle. So it can be 90, for example 90. So for 90 it will begin from here, then it will go the counterclockwise direction. So let me run and see. Then I guess you can see now it has begun from 1, then counterclockwise direction. So you can as well label your stars. You can as well label your stars. Like for example, let me create another variable here for labels. Let me say labels, or let me just say my labels, because sometimes guys, when you use the inbuilt function in R, it will have issues. So here let me just say, let me assign it to perhaps fruits. The first fruit can be apple, the second one can be banana, the third one can be apple, basically mango. I like apple so much. Mango. The other one can be something like orange, like that. And then guys, basically to pass those stuffs here, you can do it. You can add in that label. For example, it should be label, and then you assign it to that variable of yours, like it's my labels variable, and then you can even give it the main title. Can be, for example, let me say main can be fruits, as in the main title can be, let me say, fruits. Now when you run, the title will be fruits, and then I will have the labels. So let me run. Oh guys, basically here it should be label. It should be label. This is the spelling for label. Sorry. So it should be label, and then my labels. Even the labels, here it has the error. My labels. Also, when you have changed there, should be changed here. Also, my labels. Then when you run, I think it should work everywhere. We are right here. You can see it does. So basically, that's how you can add the labels, and of course, you can specify the colors for each. Now, for colors, you just say colors. Let me just say color. Let me create a variable for colors, and then to assign, use the angle bracket for less than, then the hyphen. Then you can specify your colors. You can give it your colors, like let's say C. Then assign it to the first color. Let it be for apple to be black. Let me give it black. For it should be, I think it's red. What's the color for apple? I think it's red or purple. Yeah, I think it's red. And then the color for banana, let me use yellow, and then the color for mango, I think it's also mango, I think it's green. Mango is green. And then I'm not sure of these colors, but for orange I can give it even I can give it even orange, right? I can give it orange. I can give it even orange. And then guys, for colors, if you want to pass colors, just say COL, then you pass in your variable for colors, which is color. And then when you run, it should have those colors. If it do not bring the colors, then I will just know that you have the error somewhere. Of course, you have the error. We forgot to add the comma here, separate arguments. And then wow, color name, invalid color name. So so here should be it should be no guys, basically it's not a string. We should just pass in. Remember, this one is a variable, so you just pass in color like this. Then when you run it will be colors. I'm sorry guys, there was background noise for the washing machine, but it is off now. Now let's continue. Guys, I was talking about the legend. How do you add the legend? To add a list, basically this is kind of a list of explanation for each pie, or yeah, basically of each pie. Now we use the legend function. So like, let's add in what? Let's add in another parameter here for the legend. Like I can just say, let me just say legend like this, and then this legend, the positioning is gonna be, let me position it at the bottom right. Like let me just position it at the bottom, bottom right, or bottom left, or wherever you want it to be. And then it's gonna have my labels. So you pass in the item that you want. It should be my labels. That's the object. Is it my labels here, right? My labels. And then the colors field is gonna be the colors variable. It is color, just color, like that. And then what I do, let me run and see if it will have that legend. Yeah, guys, you can see now it's available here at the bottom. So basically that's how you can add the legend. And of course you can add in top, left, top, whatever you want. But let me talk about the bar charts. So guys, let me now talk about the bar charts. Now guys, basically a bar chart uses rectangular bars to visualize data. Now bar charts can be displayed horizontally or vertically. The height or length of the bars are proportional to the values they represent. So we use the bar plot function to draw a vertical bar chart. So like so remember bar, it has the x and the y axis. So for x, for example, if you want to define your columns or your bars, you can use, for example, let's x, then assign it um, to this. Remember, we use the C to join values. This one is for vectors to join dash value. For example, the first one can be column A or bar A. The second one can be bar B. This third one can be should be bar C. The last one can be perhaps. You can add into your preferred, or even you can use the month name or whichever thing that you have on your data. So it can be D. And then so this is for x-axis. Now for y-axis can be the values now y. Then you assign it to the values like can be what can be there are 4 items, like it can be 2, 4, 6, and then 8. Now to plot that bar graph, we use the bar plot. A bar plot, and then this one will draw a vertical bar, and then here you are passing out the y, and then also we use the name arguments for x to define that this is the name, this is the bar name. Like use the name argument here, and then we are passing out x. Then let's try to run and see if it will work out. Yeah, guys, you can see now it is work. We have visualized it. So guys, basically that's how you can do that. And so basically these are the x-axis represent the values of the x-axis, that is A, B, C to D. Then the y represent the values in the y-axis, like the first one will head to 4, 6 to 8. So guys, you can as well give it the colors. For example, you can give it even the colors. The colors, you can say, for example, here you can just pass in the colors and just say call for color, call. Then you can assign it to your color, like if it's red or a blue. Let's use blue. Let's use blue, and then let's run and see if it's yeah, guys, you can see now it's blue. So you can as well change the texture. You can change the bar texture with the density parameter. So so we just say for example, if you want to add the density here, just say density, then you can give it even your density here. Then when you run, you'll have this kind of a stuff here, so it will be slashed or such stuffs. And of course, guys, you can already change the bar width with the so width, you just add in this property called width. Then in the width, you can pass in your values 1, perhaps 1, 2, 3, 4, 4. And then what I do, so the first one will be smallest, biggest, I think, or a smallest, smaller, small means means small, I don't know. It also, it should be C. We should use the C to join the values. Let me run again and see if it will work. Yeah, guys, you can see it does. So it is small, big, bigger, small, smallest. Yeah. And so basically that's what you can do. Now for horizontal line, you do what you have to specify. These are property called horizontal. Horis. You assign it to a true value. If you want a horizontal, you assign it to a logical value here, which is true. And then you separate with a comma. Then Let's run and see. Yeah, guys, you can see now it is horizontal. So basically this is all about the bar graphs. So guys, let's now talk about the statistics, R statistics. And first of all, let's understand what is statistics. Statistics is the science of analyzing, reviewing, and concluding the data. Some of the basic statistical numbers include the mean, median, and mode, and also have the minimum and the maximum value, percentile, variance, and the standard deviation, covariance and the correlations, probability distribution, and so forth. Now, guys, let's begin. Let me talk about the data sets. And the data set is a collection of data, often represented in a table. If you have a table and it has some stuff, some content, so those content are what we call the data sets. Now, in this example, guys, in this tutorial, in this course, I want to use here some building data sets in R called the empty cars. Empty cars stand for motor, trained car road test, which are retrieved from the that is 1970 Motor Trend US magazines. Now, guys, basically for that, let me just show you to print it out, guys. The values for datasets for empty cars, just say empty cars. So when you run, it will print the values. So now let me just minimize this section because I no longer need it. Then let me maximize this section. Let me maximize, and guys, we have a lot of stuffs here, but first of all, let me clear, and then let me run it again. This one is also is much big. Let me run, and then so guys, I basically can see it has printed out these stuffs here. So basically it has printed out these stuff. So I want to use these data sets in this course. So basically how do you obtain the information about the data sets? So okay, so basically to obtain the information about our data sets, we can use the question mark to get the information about these empty cars. So we just begin with a question mark. Where's the question mark here? Yeah, here it is. Then when you run, it will give you the information about the cars, and then you can see on this other end we have the information about these cars. So so basically this is how you can obtain the information, and you can see it is there. So basically also we can use the dim function to find the dimension of the data sets, and the names function to view the names of the variables. So like, let me show you. For example, if you want to, let's begin now. Let me use dim. First of all, guys, let me just say, let me begin first of all to get the. Let me first of all our data sets for our data cars. Let me assign it to the empty cars, empty cars, and then dim. Remember, dim I said is a function to find the dimension of the data sets. So I say dim, and then I'll assign it to that data underscore cars, and then now for names. So for names, I'll say names, and names I'll assign it to now these data cars again. Data cars, because I want to obtain also the names for the cars. Then what I do, let me run and see if it will output the results. And then I guess you can see it has done that. You can see the dimension here, and then now the names, so basically that's how you can do that. And we use the row names function to get the name of each row in the first column, basically in the first column, which is the name for each car. So guys, basically in that case, what we do, I'll have to do this. Let me just here, let me just say row names. Row names, and then in this row names I'll pass in data cars. Then what I do, let me run and see if it will. Yeah, guys, you can see it has given us the names here, basically the row names. So basically This is our sample data, and so guys, let me talk about the print variable values. So if you want to print all values that belong to a variable, then access the data frame by using the dollar sign and the name of the variables. For example, if let me just show you an example here. Let me just show you an example. For example, if you want to obtain, first of all, let me just say data, the data class, and then for example, if you want to obtain the cylinders here, you can just use this the dollar sign here, and then we do it. So just say CSL like this. Then when we run, it will do it. It will access the data frame with these cylinders. Let me run and see if it will give us. You can see, yeah guys, it basically does. You can see you have obtained the results. And then how do we sort the variable values? To sort, we just say here sort. We just use sort, and then these other stuff should be inside the parentheses like this. Then we'll sort your values. Then guys, you can see now 4 are in a different category, basically 4 separate, 6 separate, 8 separate. Now that we have some information about the data sets, we can start to analyze it with some statistical numbers. For example, we can use the summary function to get a statistical summary of the data with the let me just do that. Let me just show you. So let me just say summary, and then I pass in your data class, and then let's run and see if it will print out here. Guys, you can see now it has given us the more information about this class, the summary. Now guys, basically I want to talk about mean. You can see here we have the mean, medium, mean, first basically first quantile, that is percentile. This is first quantile, that is the percentile. Then we have the median, then we have the mean, and then we have the third percentile, basically third quantile, that is percentile. Then we have the max. So I want to talk about these stuffs as we go on. Let me just talk about, first of all, let me begin with the max and the mean. So guys, basically we have just introduced this empty class, which is our data set, which is built in this R. Now guys, basically we have several math functions in this R, and I talked about the mean and the max, right? The onset of this course. So basically max is used to find what the minimum value, and that is max. Max is used to find the maximum value. Mean is used to find the minimum value. So guys, I want to use this data here to find what the minimum value and the maximum value. So for me, we just say max. For maximum, it's just say max, and then you say data class, and then you have to add in this other argument here called HP. Guys, basically to find the highest, basically the largest and the smallest value of the value, you have to use the HP, that is horsepower, to find the highest value here. Like you just say dollar sign, then HP, highest power. Then also for mean, let me just copy. Let me copy, and then let me just paste it here. And then here should be mean. Let me change it to mean, and then also let me just run and see if it will output here. Okay, as you can see, the highest is 335, then the other one is 52. Let me talk about something else, guys. Let me talk about the mean. Basically the mean. So in statistics, there are often three values that must interest us. That is mean, that's the average of the value. We also have median, we shall talk about it later. That is the middle value. Then at the mode, that's the most common value. Let's begin with the mean. Now guys, basically to calculate the average value or a mean of a variable from perhaps these empty class built-in data set in our R, we can do what we can do that. We can find the mean. So first of all, let's find the sum of all the values, and then I shall divide by the number of items. Now in R, we just do this. To find the mean, remember, to find the mean, you add every values. If you want to do it manually, you add all the values, then you divide by the number of items there. So like for example, but in R it's easy. Just say mean, then you pass in what your data, your object here, your data sets, and then use this dollar sign. Where is the dollar sign here? And then here just passing WT for that cast. Then what I do, let me run and see if it will print out here. Guys, you can see now the mean is 21. The mean is 3.21725, right? So guys, let me now talk about the median value, of which is the value in the middle after you have sorted all the values. So it will take a look at the values of the WT variable from this case we are using empty cast. Let me say median, median like this. Then let's run. Yeah, guys, basically you can see it is 3.25. So guys, let me talk about the mode. Now the mode is the number that appears many times than the others, and in R we use this function here called it's called what is called names. First of all, names, and then in these are names here you pass in what you sort. First of all, you sort, and then after you've sort, then first of all is passing negative table. You sort this table, then I pass in your data sets. That's our data come, and then end W P. It must be in the pair of these two arguments here. But first of all, the data sets and these are WT. Then what I do, let me run. So guys, it has sorted out our stuffs, but if you want to obtain the mode, you use these parentheses, and then I specify 1. Then when you run, you'll get the results here. It is 3.44. So basically, that's how you can find the value of the of the mode. So guys, let me now talk about the percentiles, and percentiles are used in statistics to give you a number that describes the value that a given percent of value are lower than. So if we take a look at our values, our WT weight or a weight of our items here, basically of our variables in this empty cast, guys, let's try to find the our items here, basically our percentile here. First of all, so guys, let's now try to find the quantile here, or the upper percentile that we want to find. For example, if we want to find the upper percentile, that should be 75. So first of all, you use the quantile, and then what do? You say you specify your data sets. It is data sets, the basically data underscore cast, and then with the weight WT, and then what else? You pass in your percentage that you want. It is upper what? Upper. I want us to obtain the upper percentile here. Third, it should be third percentile, right? So it should be C. Then you pass in what? 0.75. That should be upper percentile. When you run, it will give you the result, which is 3.61 in our case. Now for what? For if you just want to, if you run the quantile function without specifying this C, our vector here, you'll get the percentile of 0, 25, 50, 70, 75, and 100. So let me just remove these stuff and show you that. So if you don't specify, then when you run, it will give you the 0 percentile, upper 25 percentile, 50 percentile, 75, and 100. So guys, basically this is all about the percentile, and of course this is the end of the course. And guys, you can realize that the R is very easy, and you've gained a lot. Now guys, I urge you to subscribe to this channel, like and share the video to your friends, and to the returning subscribers, I continue to thank you. And guys, let's meet in the next course. Or I think it should be machine learning. It should be machine learning. Then I shall talk about the artificial intelligence, and then I shall talk about other stuffs as well. But for now, I appreciate you very much for your time.